Hello class, in this video we're going to be looking at valence electrons again and Lewis dot diagrams, and the main focus is how to make these Lewis dot diagrams and how we're going to use those in the future. So I'm going to first review valence electrons and how to calculate how many a particular element has. So again, valence electrons, these are the outermost electrons, or the electrons on the highest energy level, so the outside electrons. And the reason why we're so interested in the outside electrons, the ones on the outer ring here, is because those are the ones that do all the reacting. They do all the interacting with other elements, and based off of the number of them, we can figure out the reactivity of the element. So again, there's a couple ways that we can calculate valence electrons. If we look at the electron configuration, and we just count up how many electrons are in the highest energy level, well, we only have two energy levels here, 1 and 2, so 2 being our highest. And we have two subshells, S and P, and we just add up all the electrons that are there, 5 plus 2, 7 electrons. Or if we look, or 7 valence electrons. If we look at the Bohr's model, and we just count the ones on the outer ring, counting there, that's 1, 2, 3, 4, 5, 6, and 7. We get the same answer. Again, with magnesium, if we're looking at magnesium, we have 3 energy levels this time, 1, 2, and 3. So our highest energy level would be 3. It only has one subshell, the S subshell, and in that subshell it has 2 electrons. So we're going to have 2 valence electrons here for magnesium. Again, you can look at the Bohr model and see 1 and there's 2, so we have 2 valence electrons. The other way that we can look at, and we saw in a previous video, is just by the trends on the periodic table. We know that group 1, all of group 1 here, if we go right up top, this should be on your periodic table, has 1 valence electron. Group 2, anything in this group here has 2 valence electrons. Group 3, or 13, 3 electrons, and so forth. And so we can figure out how many valence electrons are in an atom just based off of its location on the periodic table. So what do valence electrons have to do with the Lewis dot diagrams? Well, we see Bohr's model, and it's a nice depiction, but it has more electrons than just the valence electrons. So in the Lewis dot diagrams, we're going to see that we're only using these valence electrons. So Lewis dot diagrams, and here's the definition here that we should be using. It just represents the valence electrons as dots around the element symbol. So I do have some examples set up here that I want to do with you. So let's first look at fluorine. So the very first thing I need to know is how many valence electrons does fluorine have. So I can look at my periodic table, find fluorine, go up to the top, and I have it labeled 7 valence electrons. So now I know, okay, there's 7 valence electrons here on fluorine, so it's going to need 7 dots. And the dots need to go in a particular order. Basically, just imagine there being a box around fluorine, and it can have 2 on each side, no more than 2. I don't want a whole line of dots here. So there's 1, 2, and I just keep going around until 3, 4, until I have 7, 5, 6, and 7. And so that's my Lewis dot diagram for fluorine. Let's look at magnesium. So again, the first thing I need to do is figure out, well, how many valence electrons are there? Here's magnesium, go up, 2. So I know that I have 2 valence electrons, that means I need 2 dots. So again, I just pull over dots until I have 2. There's 1, 2. Let's look at oxygen. So you might be able to do some of these on your own now. So let's look at oxygen. Here's oxygen. It has 6 valence electrons. So going back, we know we have 6 valence electrons, and so it should have 6 dots. 1, 2, 3, 4, 5, 6. So we have 6 dots there, and that's my Lewis dot diagram for oxygen. Let's look at these last two here. We have lithium. So back to my periodic table. Lithium, go up. Okay, it has 1. So it's only going to get 1 dot. So 1 valence electron. That means it's only going to get 1 lonely dot. And then neon. Neon's going to be our final one in this example. So let's go to our periodic table. Here's neon. It has the maximum amount, which is 8. So that's something that you need to know. If you are making a Lewis dot diagram and you have more than 8 dots, you did something wrong. You should never have more than 8 valence electrons. So you shouldn't have more than 8 dots. So again, 2 on each side until we're full. So that's 1, 2, 3, 4, 5, 6, 7, and 8. And you can see that's completely full. We have 2 on each side, so there can't be any more than 8 valence electrons. So hopefully this video helped you, and you can do your own Lewis dot diagrams. And if you have any questions, please bring them to class.